Hey everyone, what's up? So here's something super cool. A PCB board themed after Goku from Dragon Ball. The idea here was to make a simple PCB badge that includes Goku. I place a few LEDs on this board in such a way that when it's being driven by an Attiny13, it glows in a chasing pattern and it creates an illusion of Goku firing his famous Kamehameha wave. For those of you who don't know who Goku is or what is Kamehameha wave, well, Goku is an alien from outer space who was raised by an earthling and he fight bad guys. Basically Japanese Superman. This PCB is a version 2. I already made its version 1 back in 2021 and it was pretty functional. The only problem with that version was I use Attiny13A in that, and right now Attiny13A is pretty hard to get because of the chip shortage. So I modified my design and use an Attiny13A instead. In this video I'm gonna show you guys the whole build process of this badge. So let's get started. The design of this PCB badge is pretty simple and straightforward. To drive LEDs, I have used MOSFET which is controlled by an Attiny13A. 5 MOSFETs are being used and each of them drives 4 LEDs that are connected in parallel. I made this schematic in my OrCAD PCB suite and then converted it into a board file. The main attraction of this PCB was the Goku image or sill screen that I have placed on its top side. What I did was I searched for a black and white Goku image and then converted it into a BMP image as my OrCAD PCB suite only import images in BMP format. After importing the image of Goku into my PCB design as a sill screen, I place all the component around the board and finalize the design. LEDs were placed in the shape of a ball or an orb that is being fired from Goku's palm. After finalizing the PCB, I sent the Gerber data to PCBWay for samples. I choose yellow solder mask for this project with a white sill screen. I've added graphics on the top side of the PCB to increase the aesthetic of the PCB. Quality of the PCB that I received was just awesome. I have been using their service for a while now and I have to say, it's pretty decent for getting started. Check out PCBWay for getting great PCB service at a less cost. The PCB assembly include the following steps: solder paste dispensing process, pick and place process, and hot plate reflow process. Now before adding the coin cell holder, I tested whether LEDs were soldered properly or not by using a multimeter set in diode checking mode. I connected the positive probe of the multimeter to the positive of first column and negative to its negative terminal. After testing that each LED is soldered properly, I then move on to the next process, which was to add an SMD coin cell holder on the back side of the PCB. This SMD coin cell holder is the only component in the PCB that is not being placed by a solder paste. After this, we just need to flash the Attiny13A with the main code and power this board up. Here's the code that I use. I made some changes in it which include changing the pin number as the previous version has a different pinout because it utilizes Attiny84, but now I'm using Attiny13A. As for the upload process, you can check out my previous video about this topic. But basically, I had to manually solder 6 wires to MCU's SPI pin and then connect it with the Arduino Nano, which was then flashed with the Arduino ISP sketch. Here's the result of today's build. With a little bit of creativity, we can convert anything into a PCB design, which was kind of like my goal here. The Goku version 2 is working properly as it should, and now I can finally say that this version is the final one and it doesn't need any further development. Special thanks to PCBWay for supporting this project. You guys can check them out if you need great PCB service at an affordable rate. This is it for today, folks. Thanks again, and I'll be back with a new project soon. Peace out.